Okay, everybody, hello. Today we are going to look at the last section of chapter 9.8. We're going to talk about sum and difference identities. It is also the last section of Algebra 2 for the year. So I am sad to say this is, or maybe you guys will be happy, but this will be the last video and the last new thing that I teach you this year. So hopefully you will enjoy this. I think it's fun. But here we go. So we're going to talk about sum and difference identities. So you'll notice I started, I have the identities up here partially. There's no signs, right? We have all these random spaces. So I'm going to write that part in while I talk and explain it to you. So sum and difference means we're talking about addition and subtraction, right? Sum and difference. We talked a little bit about, or I think I mentioned this at some point along the way, or maybe it was on a Zoom meeting, I don't know. But what the sum and difference identities will allow us to do will allow us to evaluate some trig functions at angles that aren't part of the special right triangles that we've already talked about. So for example, you can find the sine of 30 degrees or the cosine of 135 degrees or the tangent of 360, oh, that's a bad example, 330 degrees, because all of those have reference angles that are either 30, 45, or 60, right? So as long as our angle has a reference angle of 30, 45, or 60, or is an actual quadrantal angle, so an angle that terminates on an axis, we can evaluate those trig functions no problem. But the problem then becomes, what happens if we want to evaluate, let's say, for example, the sine of 75 degrees? Well, 75 degrees has a reference angle of 75 degrees. And do we know the ratio of the sides of that triangle? We absolutely do not. So we need some other way to be able to evaluate that. And that's one of the things that we can use the sum and difference identities in order to do. So let's suppose that our identity was the sine of A plus B. Okay, so A and B are just two angles. That would mean we would add the two angles together first and then take the sine. We can rewrite that so that the angle that we're trying to evaluate the trig function at is just a single angle and not two like we have here. So the sine of A plus B is just the sine of A times the cosine of B plus the cosine of A times the sine of B. So we're taking the sine of the first angle times the cosine of the second, and then we're going to add to that the cosine of the first angle times the sine of the second. Okay? What happens if it's subtraction? So if it's A minus B, the only thing that changes is we have a minus in between instead of plus. Okay? So for a sine, we've got a sine and a cosine together of each of the two angles, and then whatever it is, if it's a sum or a difference, then that's going to be the same sign in between. Okay? How about for cosine? So notice that cosine looks a little bit different, right? You'll notice that we have the cosine of A times the cosine of B and the sine of A times the sine of B. So the two cosines go together of each angle, and we're multiplying the sine of each of the two angles together. Okay, so what happens if we have the cosine of A plus B? I know you're all yelling, it's plus. Unfortunately, it's the opposite here. I mean, not unfortunately, but just so you hopefully don't get confused. And then if it's minus, only thing that changes is that is a plus. So I put them on top so that you know which one goes with which and tried to color code them for you. How about the tangent of A plus B? Tangent of A plus B is the tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B. So the sign in the numerator is the same as what we have between the two angles, and then the denominator is the opposite. Okay? And then if it's tangent of A minus B, then these are just reversed. Okay? All right. So you know how I feel about memorizing, but these are, this will be something that you're just going to have to stick in your brain. So are there ways to derive these? Yes, you will do that in pre-calc. For the time being, you're going to accept that I am not lying to you, because I have not lied to you and I won't. Okay, so let's do an example. So we mentioned the sine of 75. Let's do that. We want to evaluate the sine of 75. So what we need to do is we need to come up with two angles that have a reference angle of either 30, 45, or 60 that we could use and rewrite this 75 using those two angles and using either addition or subtraction. Okay? Is there only one possibility? No, for the vast majority of these, there's going to be more than one possible pair of angles, and you can choose any one that works. It makes no difference. Okay, so we could make our life as simple as possible, right? Because we like that. We could change this to 30 plus 45, right? Obviously, 30 plus 45 is 75. We know the sine of both of these angles, so let's use those. All right, now all we're going to do is expand using our sine identity. So when we expand this, we get the sine of 30 degrees times the cosine of 45 degrees, and then our sign in between, SIGN, will be the same as what we have here, so that's going to be plus. Okay, this time we have the cosine of 30 degrees, and then the sine of 45. Now, it's just a matter of evaluating those. So yay, hopefully you remember your unit circle at this point. The sine of 30 degrees is 1/2. The cosine of 45 degrees is root 2 over 2. Cosine of 30 is root 3 over 2. And the sine of 45 is root 2 over 2. So now if I multiply these two fractions together, I get root 2 over 4. If I multiply these two together, I get root 6 over 4. And since they have a common denominator, we could just combine those. So we get root 2 plus root 6 all over 4. Awesome. Not so bad, right? Okay, let's try one more, and then we'll see what else we can use these identities to do. Let's suppose that I gave you the tangent of pi over 12. All right, so I had to go and mess things up by putting those darn radians in there, right? So again, we're going to think in radians, and I'm not going to convert that to degrees and then try and use degrees. So see if you can think of two angles that you could either add or subtract to get pi over 12. So pause me and think about that for a second. What two angles can you either add or subtract to get pi over 12? Okay, so hopefully you figured something out, but let's just think about it like this. We could do 11 pi over 12 and 10 pi over 12, right? If we subtract those, we're going to get pi over 12. Well, does this combination work? 10 pi over 12 is really 5 pi over 6, and we could evaluate that, but we don't know this one, right? If we think of any two consecutive angles, right, any two consecutive integers here, 11 and 10, 10 and 9, 9 and 8, so on and so forth, right? We could keep going. Then those are all going to work, right? Because that would give us pi over 12. So we just need to find two that when we reduce, they're going to be things that we can evaluate. So let's say, for example, we had 4 pi over 12 minus 3 pi over 12. Well, that's clearly pi over 12. And 4 pi over 12 is pi over 3. 3 pi over 12 is pi over 4, right? We know both of those. So this one would work. Is that the only one? It's not. Can you think of another one? Sure. If you said 9 pi over 12 minus 8 pi over 12, that would work, right? Because this is 3 pi over 4, and 8 pi over 12 is 2 pi over 3. And again, we could evaluate both of those. So if we choose these, which is totally fine, we just have to be careful about which quadrant we're in, right? When we evaluate, when we expand. If I use my first quadrant angles, then that makes life a little bit simpler, right? Because I don't have to worry about that. So I'm going to choose these two, but again, it doesn't make any difference as long as the two combine to give you pi over 12. So I'm going to write tangent of pi over 12 as pi over 3 minus pi over 4. Okay, and could you also write it as pi over 3 plus negative pi over 4? You sure you can? Again, you just have to be careful with your signs. I'm going to do it as a minus just so we can look at an example of that identity with the minus. Okay, so we are going to expand this. So we get the tangent of pi over 3. Our sign in between, remember, is going to be the same as what we have here. So this will be minus the tangent of pi over 4. All over, remember these two signs are opposite. So this will be plus tangent of pi over 3, tangent of pi over 4. Okay, now it's just a matter of evaluating. So the tangent of pi over 3 is, it's a real test to see who knows their unit circle, root 3. Whoops, flying caps. The tangent of pi over 4, that's an easy one, right? And then in the denominator, well, we've already done both of these, so this would just be root 3 times 1, which is root 3. Okay, good with that much? Hopefully. All right, but wait, there's more, of course, right? So the problem is we still have a radical in the denominator, and we need to get rid of that radical from our denominator. In order to do that, we will multiply both the numerator and the denominator by the conjugate of the denominator. So if we multiply the denominators together, remember that this will just become 1 minus 3. And in the numerator, if we distribute, we get root 3 minus 3 minus 1 plus root 3. I just distributed the root 3 to both of those, right? And then root 3 times root 3 gave me that just 3 here. And then distribute the negative 1 to both of those, so that gives us positive root 3. Okay, so now we're going to simplify. So in the numerator, we've got 2 root 3 minus 4, and in the denominator, negative 2. So we could divide everything by negative 2, and that leaves us with negative root 3 plus 2. And if you switch the order to, that doesn't matter. I just was too lazy to rewrite it, to be honest. My brain likes it better the other way. Okay, so hopefully that's good. So again, you're just thinking two angles that you can rewrite the given angle as, again, making sure that those two angles are things that you can evaluate using your knowledge of the unit circle. All right, let's try this. Let's say we are going to simplify the cosine of x minus 2 pi. Okay, so in order to simplify, the first thing we would want to do is use our identity and expand. So if we expand this, we get the cosine of x times the cosine of 2 pi. Then remember, our signs are opposite for cosine. So this is going to be plus the sine of x times the sine of 2 pi. Okay, now we can evaluate these two. What is the cosine of 2 pi? Cosine of 2 pi is just 1, and 1 times cosine x is cosine x. The sine of 2 pi is 0, and 0 times sine x will just become 0. So we are left with the cosine of x. That was fun, right? Okay, let's try. So the key here is anytime you see sine, cosine, tangent, whatever, with two angles that you're adding together, you always want to expand. Try to expand and see where that's going to take you. All right, let's try this problem. This is something that should look familiar to you because we've done things like this already. But we're going to look at another way that we can do it. Okay, so let's suppose, which one should we do? Let's do tangent of a plus b, why not? Okay, so let's suppose that we know that the cosine of a is negative 12/13, and a is between pi over 2 and pi, and the sine of b is 3/5, and b is between 0 and pi over 2. And what we want to do is determine the value of the tangent of a plus b. Okay, so what's the very first thing we're going to do? Well, first thing we're going to do is we're going to take the tangent of a plus b and we're going to expand it, right? If we expand this, we get the tangent of a plus the tangent of b all over 1 minus tangent a, tangent b. Okay, in order to evaluate this, we need to know the values of the tangent of a and the tangent of b, right? Well, how can I find those? So you've got two choices. You could use your Pythagorean identities like we looked at in the last section, or you could draw a triangle. It's totally and completely up to you. I'd probably use the triangle I would suspect many of you would as well, but you do whatever makes you happy. Let's say this is angle A. That doesn't look anything like an A. Looks like a, I don't know, just a squiggle. I was going to say a bird, but that'll tell you how good my bird drawings are, right? Okay, so let's suppose this angle is A. If we know that the cosine of A is negative 12/13, I'm going to ignore the negative for a minute. We'll come back to that. So 12/13, that means the adjacent side has to be 12, hypotenuse is 13, and that means my missing side, my opposite side is, hopefully you remember your Pythagorean triples. If not, you can use Pythagorean theorem, but that side will turn out to be 5, right? Okay, so let's go back to this whole negative issue for a second. We know that A is between pi over 2 and pi, right? That's what determines that this is a positive or negative value. Which quadrant are we in, or where does A terminate if A is between pi over 2 and pi? Well, if A is between pi over 2 and pi, that would put us into the second quadrant, right? Okay, so if we want to know what the tangent of A is, the tangent of A then is opposite over adjacent, so 5/12. But we are in the second quadrant, and what do we know about tangent in the second quadrant? It is indeed negative. Okay, now we're going to do the same thing in order to determine the value of the tangent of B. So we're going to draw a different triangle, right? Since tangent is just the ratio of two sides of a triangle, we've got two different triangles, one for angle A and one for angle B. The sine is 3/5. Sine is opposite over hypotenuse. That means my missing side is indeed 4. If B is between 0 and pi over 2, that puts us into the first quadrant. And we know that everything's positive in the first. So we know that the tangent of B then is positive 3/4. Okay, now all we're going to do is take our tangent values and substitute them into the appropriate place. So we know that the tangent of A is negative 5/12. And we know that the tangent of B is 3/4. And then in the denominator, when we substitute in, tangent of A is still negative 5/12. And tangent B is still 3/4. Sorry, I had to color code so that everything matched. One, because it's visually appealing, and then you can see where all the numbers come from, and two, well, it's my last day to teach you something, and I really should go all out with my markers and make it fancy, right? Okay, so now it's just a matter of simplifying. This should not be the hard part, right? Hopefully. We've got negative 5 pi over 12 plus 3/4, which is 9/12, right? So this gives us 4/12. Can I add? See, I say this shouldn't be the hard part, and then I'm the one going, is that right? So I believe this is equal to 4/12. And then in the denominator, since this is a negative, right, when we multiply, this is going to become 1 plus. This will be 15 over 48. Okay, so yes, I could have simplified along the way, but I usually don't when I do these, and I'll just simplify at the end. Easiest thing to do, I think, is to get rid of those fractions rather than getting common denominator and flipping by everything. I could just multiply the top and the bottom by 48, right, of that large fraction, like we would simplify a complex fraction, since that's what it is. So this just becomes 16 over 48 plus 15. So 16 over 63. And that is the tangent of A plus B. Isn't that fantastic? Get to use so many things in one problem that you've already learned. I love those. You know how much I love those problems. Okay, let's do one more thing with this, and that is going to be to solve some equations. I think I'm going to get rid of these just so I have some more space. Okay, so let's solve an equation. Which one shall we solve? Should we start easy or hard? Maybe we'll do one of each. I don't know. Let's try this one first. How about the cosine of x plus pi over 4 plus the cosine of x minus pi over 4 equals 1. Okay, so since we're taking the cosine of a sum and the cosine of a difference, we're going to expand each of those first. So if we do that, we get the cosine of x. Oh, I didn't give us a domain. We're going to solve for all x between 0 and 2 pi. Okay, so cosine of x times the cosine of pi over 4 minus, because remember these are opposite, sine x sine pi over 4. Well, I definitely don't have enough room on my board for this one, do I? All right, and then when I expand this one, this is going to become the cosine of x times the cosine of pi over 4. And I have to put that underneath here, plus the sine of x times the sine of pi over 4. And that is still equal to 1. Okay, so far so good. So all we did was use our identity to expand each of those expressions. All right, now what happens? You notice that we've got sine x sine pi over 4. One's positive, one's negative. Ever satisfying canceling. And then these two terms are the same, so we can combine those. So we get 2 cosine x cosine pi over 4 equals 1. Okay, now what? All right, well, 2 things, right? 1, I could divide by 2, so this becomes 1/2. And then secondly, we know the cosine of pi over 4, right? We know the cosine of pi over 4 is root 2 over 2. So root 2 over 2 times the cosine of x is equal to 1/2. All right, now we are going to multiply both sides by the reciprocal, right? So the cosine of x, if we multiply by 2 over root 2, becomes 1 over root 2. And if we rationalize, that is just root 2 over 2. Okay, so now we know cosine x is equal to root 2 over 2, and we need to figure out at what angle that satisfies our given domain is the cosine of that angle equal to root 2 over 2. So we know that our reference angle would be 45 degrees, right? Is that an actual solution in this case? Sure, because it's positive, right? The cosine value is positive, and we know that in the first quadrant, which 45 terminates in the first, cosine is positive. So one of our solutions, oops, I wasn't supposed to use degrees, so was I? Oopsies, oopsies. We're solving in radians, right? Sorry about that. So pi over 4. So x is pi over 4. And then we also need to know in what other quadrant cosine is positive, right? So cosine is also positive in the fourth quadrant. If we have a reference angle of pi over 4 in the fourth quadrant, then we know this whole angle would have to be 7 pi over 4. So our solutions then would be x equals pi over 4 and x equals 7 pi over 4. Okay? I think that should make sense, right? I don't know that we need to do another one. I know it stinks because I would ask you if we want to do another one. Some of you are going, no, it's fine, just give us our homework. But since you could turn me off, oh, what the heck? You can turn me off if you don't want to hear anyway, right? Might as well do one more. Let's say we have the tangent of x plus pi minus the tangent of pi minus x equals 0. Okay, so first thing we're going to do is expand. Of course we are. So the tangent of x plus pi is the tangent of x plus the tangent of pi all over 1 minus tangent x, tangent pi. Minus, if we expand the tangent of pi minus x, we get the tangent of pi minus the tangent of x all over 1 plus the tangent of pi times the tangent of x. That is equal to 0. Okay, so far so good? All right, what is the tangent of pi? So tangent of pi, we'll be able to fill in all of these guys, right? So remember pi, we're over here on the unit circle, and we know tangent is y over x, which would give us a value of 0, right? So if tangent of pi equals 0, then what happens to this and this whole thing and this whole thing? Those are all gone, right? Satisfying or sad? I don't know. You tell me. So we are left with the tangent of x over 1, right? And here we are left with minus a negative tangent. So this becomes tangent of x over 1. So just tangent of x. Okay. Now we can simply solve this. So tangent x plus tangent x is 2 tangent x. Divide by 2. Tangent x is still equal to 0. We already know where the tangent is equal to 0, right? Tangent is equal to 0 at pi. And where else? Let's say 2 pi, right? Because we were using the same domain. Sorry, I erased it and didn't write it back down. So using the same domain from 0 to 2 pi, pi would be a solution. We know that 2 pi is a solution, but it doesn't satisfy our domain, right? So instead of 2 pi, we would like to give an answer of 0. So pay attention to that domain and make sure your answers fall in that given domain. Okay? Awesome. Well, I hope that you enjoyed that section. I hope that you enjoyed chapter 9. I hope that you enjoyed learning Algebra 2 honors. It stinks that this is my last lesson teaching you, and it's teaching you in this way. But I hope that you did enjoy the year, even though we did have it cut a little bit short in person. But one important message that I don't want you to ever forget, and we might as well make it colorful because, well, that's me, right? Just in case you ever forgot, which I know that you possibly could not forget this, right? Oops. I used every color except for the boring ones like brown and black, but I'll use brown because it's not that bad and it makes me think of chocolate, which is always nice. But math is fun. If you were sitting here in front of me right now, I would say, who thinks math is fun? Like I did on the first day of the school year. And you probably all still wouldn't raise your hands, but maybe a couple more of you would than did on the first day. And I count that as a victory too. So at any rate, that concludes everything that we are going to learn in Algebra 2 Honors this year. It has truly been a pleasure teaching you guys. If you have questions, as always, just let me know. And I look forward to seeing you guys on our Zoom meeting this week. So take care and have a great week, you guys.